Hey guys, this is Jeremy. The purpose of this video is to help you understand intermolecular forces so that you can get your homework done. There's a lot of stuff that we should have covered today in class that will contribute to your homework that we didn't. Usually I wouldn't care about this because your homework's not due till Tuesday, but this homework assigned today and the homework assigned on Monday are both pretty long, and so if you wanted to get a head start on it, or at least work on some of it over the weekend, I wanted to make sure that you had the information to do that. So hopefully this is useful. If not, whatever, you're still in the same state you would have been if I didn't do anything. So anyway, so I'm going to get started and start walking you through this. Bear with me. This is the first time I've done this writing, talking thing, so hopefully it works out well for you guys and for me. So first off, up to this point in the class, we have been talking about forces within molecules. So for example, if I have a HF molecule and these are covalently bonded to each other, then we could draw this arrow and say that there's a dipole in that molecule, and that because fluorine is more electronegative than hydrogen, the electrons are going to get pulled towards fluorine. Well, that is an intramolecular force. What that means is that those forces are happening within a molecule. Okay, just like intramural sports, right? Those are sports among people within your school, versus intercollegiate sports, which would be sports, athletics against people not in your school. So we are now breaking into the realm of intermolecular sports. Wow, intermolecular, not sports, forces. Wow, you tell I'm tired, it's Friday. Okay. So we will be talking about intermolecular forces. So basically the forces that are attracting different molecules to each other. Well, in general, the only force that will really attract two things to each other is the hydrostatic force. And if you remember hydrostatic force, that is the force that attracts two charged particles. I guess I could write that. And that is defined by Coulomb's law, which again is that the force is proportional to the two charges and inversely proportional to the distance between them, or the radius squared. So again, you don't have to do math with this, but this is the exact same type of force that we're dealing with. If your charges are stronger, your force of attraction is going to be stronger, right? Same thing that we talked about before. So so we're going to be looking at the different forces, the different intermolecular forces, and I'm going to make a little chart here. One column is going to be thing 1, second column is going to be thing 2, and then I'm going to have the name of the force, and then I'm going to have an example. So then these forces are named based off of the type of charge that the two molecules interacting with each other have. So to give you an example that you're familiar with, if thing 1 is an ion and thing 2 is an ion, then the force that attracts them is, believe it or not, called ion-ion. Okay, we've previously just called this an ionic bond, but more appropriately we would call it an ion-ion intermolecular force. So an example of this is if I have Na plus and Cl minus, those two things have charges, right? What types of charges? I would say that these each have a full charge all the time, or a full permanent charge, right? That charge never changes. And so because the sodium is positively charged, chlorine is negatively charged, there is going to be an attraction between them. Draw it as a dotted line, okay, because a solid line would represent sharing electrons in a covalent bond, and these aren't doing that. These are just attracted to each other. Okay, so why do we call this an ionic bond? That's just because the force of attraction is very, very strong, similar to what we see in covalent bonds. So because of that, we sometimes call it an ionic bond. But again, this is just ion-ion intermolecular force. Okay, cool. Well, what are other ways that molecules can have charges on them? Okay. One way is to have to be polar, right? If a molecule is polar, that means that it has a partial charge on it. Okay, so I'm going to skip some space on this chart just because I'll come back